Okay, cool. All right. So let's look at our test 2. So this was the example test I used, or this is a example test. This is the actual test I used last semester. Okay. So for this programming problem, and I had a lot of 100% on this test, so people did well. Okay. I had a few 90s, a few 80s, you know, but the average was actually pretty good. All right. For this programming problem, you're going to make a table to display the velocity of water through piping of different diameters given the water flow rate. So a table kind of like your homework. Okay, and I'm assuming everyone got their homework done. The equation to calculate your velocity, and it doesn't really matter what the equation is, but you just have to know how to program it. Okay, so just note that this variable here is your water flow rate. Okay, V is your water velocity, so we're calculating the velocity. This is our water flow rate over 3,600 times pi times the diameter of the pipe over 2 squared. Okay, so note that, you know, your programming project IB will have some type of equation in it, like that you'll put into a method. Very similar. For this problem, we're going to assume that the water flow rate is constant, and it's this number, whatever. So that means we plug in this water flow rate as that number. So you don't have to understand water flow rate and all that junk. You just say, okay, I know how to program that. I can program that. You're to make a function that's going to calculate and return the velocity through a pipe, given the diameter of the pipe and the water flow rate. The header for the method will look like this. And during your test, I will give you the header for your method, kind of like how we've been practicing. And in your programming problems, you know, I can give you the header. Write your program to create a table that looks like the following. So in your program, you'll do the same way. You'll just make a table to look like the following. Kind of like your homework problem, right? Now you're going to find out how long it'll take to fill a water tank with the following dimensions of the cylindrical water tank. So this was, if you finish this part up to here, you know, that was passing. And then this part here would be like a B, and then this last part would be the A. Okay. So let's see here. Remember that the volume of a cylinder can be found with the following equation, where R is the radius of the tank and H is the height of the tank in meters. And the answer is the volume of water in meters cubed. Write a method that finds the volume of a cylinder given the radius and height, and the method will look like this. So you're writing a method that if you give it the radius and height, it gives you back the volume. You guys can write a method that does that, right? It's easy. In your main method, find the volume of a cylindrical tank with a radius of 4 meters and a height of 12 meters. Okay, you can do that. Remember that the volume that you get from this method will be in cubic meters. Find how long it would take to fill the cylindrical tank with water using a pipe that has a diameter of 2.5 meters and a given water flow rate, which is constant. So that last one was just, you know, answer that question with your program. So first parts first, let's write this first part. So we're going to write this function. And then we'll make this table. Then we'll write the second function, and then we'll see if you guys can figure out the last question. Okay? And for some reason, only like a few students figured out this last question. I don't know why. But it's actually really easy to figure out. So don't make it harder than it needs to be. All right. So let's write this function. So let's start Eclipse. So if you guys were taking this test, remember to start at the beginning. Kind of write your algorithm down because you get graded on that anyway. So, you know, you're going to jot down your algorithm. Remember, it doesn't have to be a perfect algorithm at first. If you know how to program things, you can just start programming it and then come back to your algorithm and write the rest, right? You can do that. That's okay at first to do stuff like that. A lot of my students do actually program like that at first, where they, you know, you write part of your algorithm, then you code it, and then you can go back and perfect your algorithm. And we're going to use the same standards for writing the algorithm that we did in our past assignments. Okay. All right. So I'm going to make a new project in here. I'll call it test 2 or something. And then this test 2 will be our water flow rate class. So remember, you do get graded on this too. I don't care what you call it, but you better call it with something with a capital letter. So when you make your class name, that's a standard that we need to follow, that you capitalize your class name. And not all caps, just capital. So a lot of you have followed that standard. I think there was only a couple people that I needed to yell at in their homework to capitalize their class names. And when I say capitalize your class names, I mean right here. Okay? Most people got this down. So I don't mind what you name it. You could have named it test 2 or whatever. But I do grade that you capitalize the first letter, because that's a Java standard that we learn in here. Okay? It's really kind of a coding standard. All right. Then we can check mark that we want main if you guys don't want to type it, of course. So another thing that I will grade on is having your name at the top. You should always put your name at the top. Most people are pretty good about that now. That's a good habit to get into too. It's a standard. And then at least put the date. And I don't mind how you put your comments. You can use the /* and the */ kind of comment, or you can use the // comments. Okay. In fact, I think I'll put the /* comment today. Right? Alright, so you can make your comments look like that too. So for your algorithm, I would like you to kind of follow our methodology that we've been using to write our algorithms, where you have your input, you have your output, and then you have some steps. And if you really want to make a flow chart, I don't mind. Once in a while I have 1 or 2 students who like to make a flow chart instead of writing the steps. That's okay too. Okay. But in our input to our program is, what's our input? What are things that we're going to have to know? Yeah, we're going to have to know the diameter, the water flow rate, and I think that's it. Right, diameter, water flow rate for this part of the problem. And then we'll need to know the height and the radius for this part of the problem. Okay, so we can write that our input is our diameter of our pipe. The water flow rate is given to us. And then we'll need to know our radius later on. And then the height of our tank. The radius of our tank and the height of our tank. And let me think, what else do we need in here? Remember, if you forget something, you just write it in later. And then what's our output? Almost. It's not a capital V, it's a lowercase v, which stands for velocity. Water velocity. Everyone knows what velocity is, right? It's the speed. Okay? It's how fast the water is coming out. And think about it. It's good to think about the problem a little bit, I guess. If you have a smaller pipe with the same water flow rate, and then you have a bigger pipe with the same water flow rate, which one's going to go faster?
The smaller.
Yeah, the smaller pipe, because there's more pressure, right? Yeah, so it's going to come out fast. If the same amount of water is coming out of a small pipe, it's coming out faster. If the same amount of water is coming out of a big pipe, as a small pipe, it's coming out slower. Okay, so that makes sense when you look at your table, so make sure your table makes sense. The water velocity is higher up here, and then it's slower down here. Okay. All right. So that'll be our output. You could say our output is going to be our velocity for the first part of our question, or water velocity, I should say. Water velocity through the pipe. And I'm not really into pipes or water velocity. I just looked up this equation online, okay? So notice it doesn't matter what someone tells you to program. You don't have to be into it. You should know how to program. Okay. And then for our second part of our problem, we wanted to figure out the volume. That means, remember the volume, or we have to figure out, yeah, the volume will be our output. It'll be our volume. And then the last part of our problem, we want to figure out how long it will take to fill the cylindrical tank. Okay, so we want to figure out the time. Okay, so we also want to figure out the volume of a tank, given height and radius, right? And how long it takes to fill the tank. So it's our first part, our second part, and our third part. So sometimes, you know, you want a program to figure out a couple of things. All right. So since you get graded on an algorithm anyway, it's good to write your steps down a little bit. Okay. So think about how we're going to write this problem. Look back at the problem. What would be our first step? And you could have your first step be initialize your variables even. A lot of people like to write that. Okay. So we can even have our step 0 be initialize the variables, right? We know that the water flow rate is given to us. So water flow rate is given to us as 30.562, because I gave that to you. And it doesn't matter that it's meters cubed. We know the equation works. I told you the equation works, so we can just say, okay, that's our number. That's actually a new noise. Right? That's a different buzzing. Okay. Hope nothing catches fire up there. All right. That's scary.
I think it's coming from
Yeah, I know. Okay. Let's see here. What else do we know? We're going to be given the diameter. All right. Okay. So initialize the variables. Blah blah blah. What's our next step? So we want to make that table. We can think how to make that table. It's very similar to your homework. How are we going to make that table? How did you guys make that table before? You used a method. You called a method inside of a loop. Yes, that's the signal. This is the hand signal for loop. Loop. So we know that we're going to have a loop and call our method a whole bunch. Okay? So when writing an algorithm, we could say, you know, we want to do this, you know, for I from, how many times do we want to do it? Or from diameter from 1 to 10. So we could say for a diameter from 1 to 10. And we can say do, because we're kind of following our methodology here. And what do we want to do? We'll print out the diameter. Because notice for our table, we're printing out the diameter. Printing out pipe diameter. And then what do? We print out water velocity for that diameter.
That's what was kind of confusing me for a minute. On the output, it said water velocity, which I get, obviously. It obviously says so right there on the output.
Yeah.
And then it says volume of the tank, given the height and radius. That's the bottom. That's the
second part.
Okay, so there wasn't
In here?
an output.
Yeah, not in this table, but in this part here.
Okay.
Because I did make the second part so that we had to write a second method.
Okay.
Mostly so I could ask this question. All right. Print out the diameter, and we could say call the method to find the velocity, or water velocity, and print it out. And that could be an okay thing to write in an algorithm. I'll say that's cool. Okay? I know some of my students get confused on how to write, calling the method in your algorithm. You could just put in there, hey, I called this method to find the water velocity, and I printed it. All right. After we do that, we'll have our nice, neat table. And then we're going to find the volume given a radius and a height. So we'll find the volume with a height of 12 and a radius of 4. So we're going to do that outside of our for loop because we only want to do it for one tank. We don't want it to be inside of our table. Okay. So we'll say step 2, find the volume. Or we could say, I guess I use the same kind of methodology here. Call the method to find the volume of a tank of height equal to 12, I think I said, and a radius of 4. And then we'll print it out. So we'll just say print it out. And then step 3 would be to answer that last question, which would be find how long it would take to fill the cylindrical tank using a pipe that has a diameter of 2.5 meters and the same water flow rate. Oh, it didn't paste right. So find how long it would take to fill the cylindrical tank using a pipe that has a diameter. I'd say bless you, but I don't think it's say bless you. Yeah, I know. It's okay. So 2.5 meters. Yep. Oh, and I forgot to put the height here. The height will be the same, 12 meters. I remember that during the test, everyone was like, how high is it? And the height will be 12. Wait. Oh, sorry. It was the same tank. Sorry. You know what? It was the same tank, and the pipe was that big. Okay. Fill the cylindrical tank from above using a pipe that has a diameter of 2.5 meters.
It says fill the cylindrical tank with using a pipe.
Oh.
Water.
Of water.
Oh, yeah, with water. And actually a lot more goes into like finding velocity and stuff, like the hardness of the water, but we left all that kind of scientific stuff out. Got way too complicated. So we kept it simple. Alright, that's good enough for now. So when you're writing your algorithm for your test, remember just to kind of spend a couple minutes doing it. Don't spend your whole time taking up this part of your test, okay? This is probably a pretty decent algorithm, okay, for what we need to do for our test. Alright?
When we are laying out the algorithm, does it really matter what it looks like as long as you have the correct indentation?
Well, if you do have a for loop, you do need to indent.
Right.
And if you have an if statement or like a check, you do have to sub-step that.
You want to have the step 0, step 1, step 1.1. Is that all?
As long as it's indented, it's okay. If you don't name the steps, I'm a little, because you can see algorithms that don't actually name them.
Because you could make it look like an outline.
Yeah, you can still make it look like an outline, but they should be indented. You should use indentation at least. All algorithms are almost always indented at least.
So on the test, should we just pretty much use this section should just be the questions you're answering pretty much?
Yeah.
So you could just.
Because it's a pretty simple algorithm.
Okay, so you could just take the questions you're being asked on the test, and that I just use them as.
Because if we program these steps, we'll be good.
Okay.
And we can make it more detailed later. Like I said, you kind of jot it down and you can go back later. In fact, we'll do that today. We'll go back and kind of fix it up a little bit, you know. And this is how, actually in real life too, you make your algorithm, you'll start coding it, and then you'll go back and kind of fix it. Okay. This is a pretty simple one. Your algorithm for your test and stuff won't be much harder than this.
So
Okay.
you really don't have to go in depth.
It's not like a game out. Remember how we did that guessing number game algorithm? That one was a little bit more in depth. We wrote all the steps out. This one was just asking a question, so we know it's going to be one line of code. We know it's going to be one step.
Okay.
Okay. All right. Let's program this thing now. We can do this. So we're going to start with step 0. So this helps us too, kind of jotting it down, so then we know where to start. And another thing this helps us with is every step should be like testable. So you write step 0 and then you test to make sure it works. You write step 1, you test to make sure it works. You write step 2, you test to make sure it works. And that way you always have a working program too. That's called test-driven development. Okay. So this will be our step 0. And remember, I think I commented to a lot of people too. Not a huge amount of people, but some people left these to-do stubs in their code. Remember that you can take these out. I don't grade down for this, but it just looks like you don't know what you're doing if you just leave these in here. Okay? So, you know, either change it to a different comment or just take it out, delete it. Okay? Because that, you know what this is for, right? To do auto-generated method stub.
No, what?
It's something Eclipse puts in here saying, hey, you didn't write anything in this method yet, write something here.
Okay.
It's like a to-do list. You know, they have a to-do list, where is it? In here, where is it? Show view, to-do. So like if you were working in a programming group and someone gave you a task list, you can put to-dos for certain programmers. Okay, I want you to do this method. I want your to-dos to be this method and your to-dos to be this method. So if you have a group of programmers, you give them to-dos. And you can use those to-do comments to show them what they need to do. Okay, so that's what that's for. Remember that this is an industry level kind of program. People use it in real life with programming, you know, units. And so it has a lot of tools in here we don't use. Okay, so get rid of that. Okay. All right. You can put step 0, or you can copy and paste your step, or you can even put initializing your variables. I don't mind. Or just delete it. All right. Now remember that inside of this equation, we're using variable names like Q and D and V, but we're programmers, so we're not going to use variable names like Q and D and V. You take the equation and you write out your variable names better. And just because they're using capital Q does not mean we use capitals for our variable names. We still stay to the standards and you still use lowercase variable names. Okay? So let's make our variables. We're going to need a water flow rate variable, which we already know the value of. And so what should he be? Should he be an int? This is that whole data type thing. What should he be? He should be a double, yes. Everybody in here should know that right away. Okay. So a good variable name for him would be like water flow rate. And I think I already copied and pasted what he should be over here. Another variable that we'll need will be our velocity. Another one will be, we'll need height and radius at some point. And we can even initialize them if we wanted to. I know that's the second part, but we can initialize them here. And then what else do we need? We need...
So you don't have to keep on writing double velocity.
You could if you wanted to, and that's programmer preference. And I don't mind either way, just as long as you stick to like that way. So some programmers will make their variables all on different lines. So this is what he was talking about. Okay. And then some programmers, actually more often than not, people will write their variables like this. And a lot of beginner books, maybe they'll put them all separate. But more programs I see online are written like this. Okay? And I don't mind either way. Either way is correct. And either way is acceptable. Okay? So either way. Okay. So then we'll go to step 1. We're going to have our for loop. Now you can either write your method first or you can write your for loop first. Now I could have called this guy I and that would be acceptable too, but so let's see, we want to go from diameter of 1. Now where I'm getting this is I'm going to have my pipe diameter starting at 1 and going till 10. So I can use that variable in my for loop as my diameter. It makes sense to do that. Okay. And if I called him I, that would have been okay too, but since he is my diameter, it makes sense to call him diameter. Now I can either go less than 11 or less than and equal to what? If I want to go from 1 to 10.
0 to 9.
Yeah, I could have gone 0 to 9. I could go 1 to less than 11. I could go 1 to less than equal to 10. I don't mind how you set this guy up either, just as long as it counts 1 through 10. Okay? Alright, but this is an acceptable way to do it. Alright. So in my for loop, I even have it up here. I'm going to print out the diameter. Now, the difference between print and print line is print will print to the same line, right? It doesn't print an end of line character, so I'm just going to print this diameter. And then I'm going to print I'll print the diameter, and then if you guys remember from your homework, hopefully many of you use that tab character. You guys remember you guys used the tab character? So you tabbed over. Maybe some people did the tab over. And then I'm going to print my velocity. Right? Call the method to find the water velocity and print it. Now my water velocity method I gave to you. He looks like this. In fact, we can even copy and paste him if you wanted to. Notice he gives us back a double. PDFs never copyright, right? They're always annoying. Okay, so we're going to call the water velocity with our diameter and our water flow rate. So we're going to call it with our diameter and our water flow rate. Now, of course, it's red underlined because I haven't written the method yet. He's yelling at me. Okay. So if you guys want to copy and paste that header too, notice it didn't copy and paste very nicely, but here's our header. And right now would be a good time to test things that they're working. Now, to kind of test a method before we've written the method, let's say we want to test our program right now because it's a good time to test. It's good to test as you go. It's called test-driven development. This is called a stub. Remember how it said to do, make a stub? A stub is a method that we haven't written yet, but we're just returning some dummy value just so that we can see if our code works right now. We know it's not always going to be 30. I just made up 30. But I just have it return 30 so my code will compile and work. That's called a stub method. I just made a stub. This is called a driver. This is called a stub. Okay.
How about all methods are supposed to be above the name?
They could be above or below. Actually, that's a good question. I always get that question a lot, actually.
Is it another preference thing?
It's a preference thing, and the reason that they have it usually above main, because in object-oriented design, you'll have your instance variables and your instance methods above main, or have main in a separate file. And a lot of books will follow this philosophy, but the Java rule is that they just have to be outside of main. So they have to be within the class brackets, but outside of any other method. Do you see how this is my beginning of my class bracket? In fact, I forgot to label my brackets, so I'll label them now. Here's my end of my class bracket. So your methods have to be anywhere in between these two brackets, and then outside of any other method. Do you see how each method is separate? You'll get used to seeing it like this. And we can have it above main or below main. I don't mind if you have it above or below main. I think probably more books have it actually above main, so thanks for reminding me, actually, Gabriel. Sometimes I just type fast and we make them below main. In C++, customarily in those books, they have it below main. You know. Either way's right, just, you know, stick to one way. In fact, I can even put end of for loop here. And remember, when you're copying in class, try not to look at everything, try to type it on your own, because remember, we're practicing for a test too. All right, so this is a good place to test, to make sure our code's working at least, a little bit. Make sure it's printing 10 lines, and we can see if we have a problem so far. In fact, I know we forgot something. We can see what we forgot. What did we forget? We forgot something. So we'll print our output. And it prints pretty okay. But what did we forget in our table?
The titles.
Yeah, the headers, the titles. We forgot the headers in our table. We forgot it in our algorithm too. This is actually, I forgot it on purpose so that we would say, oh, okay, I can write that back in my algorithm too. Now, if you want to put the header on this table, where would we write the headers?
For the for loop.
Yes, good. You guys remember that from your homework, right? If you put them in the for loop, then they print on every for loop. So you always write your header for your table up here. Okay, so you always write the header for the table outside your for loop. And so we want to print out, what is it? Diameter, right? Yeah, diameter. And then that tab character, we can put a tab. And then water velocity. We might have to put 2 tabs, but okay, so note that tab character's in there.
What does the tab do again? I'm sorry.
It tabs over, so it puts 4 spaces in there. This is actually considered a single character. These 2 symbols together are a single character. That's called your escape character. And and most programming languages have these. /T means tab, /N means new line. In most programming languages, okay? It's a character for a tab and a character for a new line. /A in some languages is an alarm. It makes a beepy sound. Okay? So when you change your algorithm like this, writing the header for the table was a step that we wrote in here. Now you can either do this now or later, but you would go back to your algorithm and add that step in here. You see how you kind of, oh, okay, I changed my algorithm a little bit. I'm going to go back up here and put that in there. You see what I meant by, hey, you can go back and perfect it. And you can go back at the end of the test and go fix that later. But you see how we kind of fixed our algorithm so it prints the header for the table up here? So then it matches our code. All right, so good. Let's test it again if you wanted to. You kind of can assume that it works, but that looks a lot better. So note that for my numbers, maybe I'll have to put a couple tabs in here because diameter is a long word.
You just put
You
Another
put /T/T for 2 tabs. So then it tabs twice and puts 8 spaces. Ooh, that looks nice. Did you see that?
Can you just do it yourself and just do spaces?
You could.
My tab isn't working at all.
Remember to have the slash this way. It's the one above the enter key and not the other way.
Right, I use that one.
Okay, it's the backslash one. And remember that it has to be inside of a string. So I have to have it in the quotation marks because it is a character.
It is.
And this is why we test those. This is good. This shows you why you test. So then you always have a working program. Okay? And if you got this to work so far, you can work on making the method. See if you can make the method on your own. So now we're going to make this method for real, not just return 30. See if you can start writing that math for that one, okay? It's good practice. What's it doing? Oh, it is making it. Oh, right here, print is actually, let me point that out to people. Notice that I have a print here. And this one's a print ln. Print prints it on one line without the new line character so it doesn't skip. And then print ln puts the end of line character on there so it skips the line. So when I just have print, it'll print this and then it prints this on the same line. Okay? It's good to know that. The difference between print and print line. Most programming languages have stuff like this. Print and then a print line. Okay? Alright. But this kind of shows you too, you gotta test as you go, so then you know, okay, my program's working. Test this. See if you can move on to that math function. I want to actually give you a couple minutes to try to figure out that math function before we program it together. Remember that you can use the math.pow and math.py. Remember from your math library, you'll want to use math.py and math.pow function. Okay, so during the test you will use a math function, one of those math functions, but it'll be one that you've seen before. So you've seen math.pow and you've seen math.py. And remember that it is open internet, so you can look it up on the API. You can look it up in your book. Okay, how to use those. Alright. See if you can write this guy, and then I'll show you.
Why is velocity, height, and radius underlined yellow?
Oh, because we're not using them yet. So remember, yellow underlines are just warnings. It's saying, hey, you haven't used these variables. Why are they here? He's trying to make us more efficient. Because our program will compile, and it'll compile to this large instead of this large with those extra variables. So he's saying, hey, you don't need these, delete them. So it's Eclipse helping us. Eclipse likes to help us with our inefficiencies. You're very inefficient making variables you're not using. Your red underlines are the ones that won't compile. Yellows. But see if you can figure out that math. You can even, try to figure it out together. And they should be the same numbers as what's printed out here. Okay. So if the answer's right, your first one should be this number, or this velocity. Oh, and I forgot to put my little parenthesis things in there.
I'll put velocity. Just velocity.
Dude, I don't know why, but like, my spreadsheet, it's like this little box. Yeah.
Cool.
That's all it was.
Good. Let's see who can get it. Anybody got it yet?
Just backspace and,
You guys got it already?
you know,
Oh yeah. So it should be the same answer, so you can kind of check yourself. That's the best way to check it. Oh, you know, I think it did. See the first thing? Yeah. It just printed it with the E.
Oh, you're not printing.
Yeah. So those are the answers. It just printed it for decimal. Good. overthink it. Don't overthink it. The equation's right there. Remember your order of operations. That's the important part. Order of operations, right? Parentheses around your denominator, so it's properly.
Wait,
Oh, you'll do that inside of your function. So your function right now is just returning 30.
Wait, this is less.
Well, obviously the water velocity is not 30 for all its diameter. Now you want to put like a real function in there. The one that I gave you on the top of that.
Diameter is less than
Q W divided by 3600 pi times E over 2. Remember order of operations?
Alright.
Use parentheses. Yeah, we're going to do together too. But I want you guys to at least attempt it. At least attempt to kind of write it out and then test it. You know? Because during the test, I'm not going to help you. So, you know, try to remember how to do it. Yeah, those are right. This is the answer. But that's okay. It's still right. This is in fact, I'll show you how to make less decimal places. Want to make less decimal places really quick? Or the proper amount of decimals.
I'm actually president.
the practice test online that we can look at the equations and stuff?
Yeah, this test is posted in our class assignments. Like this guy here?
Yeah.
Yeah, this is in our class assignment. This is our class assignment today. You guys are going to turn this in for your class assignment today. Okay, so I gave you guys this PDF, and remember I'm going to upload the rubric right here too. In fact, a good way to practice for your test is after we program it today, go home, don't look at the one we programmed today and try to redo it on your own without looking at it. Okay? And I'll post the next example test soon. Yes. So it'll have an equation. It'll use a for loop to call the equation to make a table. You know, and it'll ask a question about something, a little bit more math.
Would you be willing to post another problem that you did?
Yeah, so we're going to post another one Wednesday, and I can even post another one. I'll even give you another example. Okay? It's good to practice these. And it's similar to the homework, and I think we never got to that one class assignment too, which is the height and the feet. Wait, height to feet. I remember we never got to this class assignment. This is a good one too. Which one was it? The conversions between Celsius and Fahrenheit. This was a good assignment too that we never got to in class. So this would be a good one to practice. Wait, question?
Any chance you can make that extra credit?
Yeah, we can make this one extra credit. Okay, this will be our extra credit for this time around. Do this one here. And then, you know, it's good practice. Okay, remember, it's just a math equation, same thing, writing a couple of methods, calling those methods in a loop. Very similar. All right. So I saw a couple people had good success. Let me show you how to format real quick, too, before we go over the equation. So if you're still working on your equation, work on your equation. I showed some people how to format things, but this is a good way to format. So if you want to format it so it's how many decimals? Let's look here. How many decimals did I have over here? I had 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 decimals. I saw some people got the right answer, but then it was like 20 decimals. All right? It's good to know how to format things. To format things, usually you use something called a decimal format object. It doesn't matter what you call your object. You make them the same way that you make that scanner object with the new operator. And then you tell it how you want it formatted. We want to have a 0 in the front. And then we want to have 1, 2, 3, 4, 5, 6, 7, 8, 9 decimals. That's how we tell it to format things. This is called a constructor, so we call the decimal format constructor with one parameter of type string that tells it how to format things. This tells it to put at least a 0 in the front, and then if there is 9 decimal places, to put only 9 decimal place numbers in this area. Now, you might have to include the class, so if I hover over decimal format, you will have to import that decimal format class that's in the java.txt library. You can see that there when you hover. So that's your java.txt library. It adds that import statement to the top. So then we can use Mr. Decimal Format here. Now we're not using him yet, we just created him, just like scanner object. Remember scanner keyboard equals new scanner system.in. We made him the same way. So if we want to use him, you have to call him. You have to say, okay, df, go ahead and format this. Format what's in the parentheses. So I wrote this code here with the parenthesis. I say format what's in my parentheses. And that'll format it to 9 decimal places. And that's probably the easiest way to format things. That tells it to format to 9 decimal places. So then when I'm printing them out, watch, even my 30, oh, my 30 does not format to 9 decimal places. Oh, but it doesn't format to 9 decimal places because this means if there isn't a number there, then don't put it there. If I put a 0 here, oh, it doesn't like that. There you go.
Okay.
So that forces him, even if he doesn't have a decimal, stick a decimal. So that's what the 0 means. If there isn't a number there, go ahead and put one there anyway. All right? But we're going to keep it like that. All right, so did most people get their equation to work? Hopefully you did. Let's go ahead and get them to work.
So do you want 9 number signs?
Yeah, so 9 decimals, because we had 9 decimals, so that means if there is 9 numbers after the decimal place, go ahead and put up to 9, not more than 9. It will put less than 9, but not more than 9. All right. Let's look at our equation and try to program him. So when you're programming this thing, just look at your equation and then say, okay, I can do this. QW is our water flow rate. So we're going to have water flow rate divided by, now here's where I need my parentheses because my denominator is big. Okay, it's divided by 3,600 times, and how do I do pi? Do you guys remember? Math.pi, and even Eclipse helps me. Pops up when I put math dot, and then the P shows me math.pi, which is a constant. All constants are all caps. So pi is both capitalized. Times diameter divided by 2 squared.
Can you just do radius since we already have radius?
Yeah, actually, but we're giving in the diameter. You see our parameter is the diameter. So we're going to use diameter divided by 2. And note that I have to put parentheses around this guy too. And we want that squared. Math.pow. Math.pow.
And then
Comma 2. Very good. Excellent. And there we go. That is our equation. Let me make it big now. But look at your PDF and compare it to this and note how we got it. And just remember your order of operations. I had to put these. The only parentheses I might not need are these two. But if you put them in there, note that it doesn't hurt to put them in there. Okay. So my order of operations will happen like this. It'll be diameter divided by 2 first. Remember? Parentheses first. Then it'll do the math.pow. Then it'll times it times pi. Then it'll times it times 3600. Actually 3600 pi and then math that out. And then it'll divide water flow rate by that number. So note that any kind of equation, you just kind of look at the equation, remember your parentheses, do it in steps, write it out. Now we need to test it, of course. And so you test them, and then you compare these numbers to the ones that are in the document I gave you. They should be the same. Okay. They look right. Note that if I didn't do this decimal format, you can even comment out or don't use the decimal format for a second. So note if you didn't use the decimal format, what your output looks like. And note that if that happens to you during the test, remember to say, oh, okay, these are the right numbers, they're just formatted wrong. That kind of threw people off during the test, I remember. Okay? Remember that Java will help us and put it e to the negative 4 and try to write it better for us. So just note that we have that decimal format in there then. All right, awesome. Voila, we already passed our test. So doing this far would be a C at least. Okay? All right. We have some comments in here. We have our for loop. We have our method created correctly with the proper parameters, the proper return value. You know, things look, they're properly indented. This is definitely a passable test. Okay, note to self. Okay. Now let's do this part so we can get a B. Yeah, we need to find the volume of a tank. So you write your next method. So during your test, you're going to have to write 2 methods. Okay. So in our, you guys should be able to write this without looking up here, right? Write a method to find the volume of a tank given the height and the radius. And I even gave you the header. So if you look over here, you can see our header. You can even copy and paste the header. This is what the header of our method looks like. This one's actually easier to write than the other method. In fact, during the test, if you can't get one method and you can't get it to work, don't sit there and, you know, not do anything. Write your next method. Sometimes the next method's easier, right? This one should be pretty easy for you guys to create. Like you guys tell me, what should it return? How do you find the volume? There you go. Times math.pow radius squared, good, radius is 2 times height. Voila, yes, very good. Okay, so note that, you know, you guys should be able to write that without even looking on your blinders. See if you can write it. Good practice. Okay. So know how that POW function works. We use him all the time. Math.pi is good. We like him. Okay. Now for this question, or for this part of the exam, I said go ahead and just figure out. You don't have to write a table for this one, and you didn't have to include it in the for loop, because this just says find the volume of a cylindrical tank with a radius of 4 meters and a height of 12. Okay, so I do have to call it in my main. So outside of my for loop, because I already made my table in my for loop, I would just say the volume of the tank with, and I don't mind how you wrote this, just as long as you had some kind of output, with a height of 12 meters and what was it, a radius of 4 meters is and then you would call that method. actually going to call it with a mistake because I want you guys to figure out what the mistake is. Oh wait, no, this one won't be a mistake actually. So then you just call your method and you plug in those numbers. So note that you have to plug in the numbers in the right order. Radius came first, height came second. So my parameters were radius and then height. So my arguments will be radius, then height. Okay. Yes.
What's the unit for it?
For what?
For the volume?
Meters cubed.
Yeah, it'll be meters cubed. In fact, if you wanted to write that on there, very good. We could say meters cubed right here. Or you could put, some people write it like this, meters cubed. Most people understand that as meters cubed. That's just a string that, you know, prints out M with a little caret symbol and the number 3. Doesn't do anything special.
You
It
just type it out meters cubed.
yeah, you can type out meters cubed. It's fine too. Just because I used M right here, so I. So note it says right here. In fact, if I wanted a space in there, I could. And I could even format it if I wanted to. But that would give me that volume of that tank with meters cubed. And that way right there, writing this program right now, B. Excellent. B in the class. Actually, I think I gave people A's for this one too. If they got this far in the code and they made a really nice program, they got 90%, right? 90%. And then I saved the last part just for the last 10% of the exam. Or maybe I even gave them more than 90%. I think pretty much, if you got this much done during the test, you aced it. You pretty much know what you're doing. You know how to make a method. You know how to call that method. You know how to do some math. You knew how to use math functions. You knew how to format it. You know, you knew how to make some variables. You covered all the SLOs, you know, for the class. Well, not all of them, most of them, except for arrays.
Do we?
What was the answer? How much volume is that tank? 603. All right, now see if you can figure out now this last one. I'm going to see who can figure this out. And once you figure it out, don't tell everybody, okay?
What's wrong with it?
No, this last question.
Oh.
Actually, nothing's wrong with our thing. I thought I was giving in the diameter up here, but we gave in radius, so we're cool. We're good.
Show
Oh, sorry, go.
your print. What you have.
Oh, okay, so we can show our output. Our output, I outputted the table, and then you could either skip a line or right after the table, you just output, hey, the volume of the tank is, and I put 6, and the answer was 603. I think that's the right answer, I remember.
Do you want that formatted as the same decimal format?
You could. If you wanted it the same, you guys should know how to do that. You just take that same DF object and use them to format your volume. So whatever you wanted formatted, you just tell it, you put it in that format function. So I want the volume formatted, I say DF, go ahead and format him. And then he formats him to 9 decimals for me. That would be acceptable, that's perfect. Wait, question?
On mine with the decimal formats,
Is he red underlined?
yeah, mine too.
You might have to hover over decimal format and tell it to import that library. If you hover over him and then go to that first quick fix, it will write this line of code at the top. Alternatively, you could just type this line of code, but he might not know what decimal format class is. He's in the java.text library. So that's what that does, it includes it in there. So then he knows what that class is. Notice I know he's a class name because he's capitalized, right? That's why we do that capital lowercase kind of standards. And voila, that's a beautiful test. This would be, I'd be like, oh, yes. Notice it didn't take us that long. I programmed really slow, so, you know, if you were to do this really quick or fast, you could finish this test in 20 minutes. Okay. I give you the whole hours, you know, how to perfect it. Note that I'd come back up here and make sure my algorithm looked nice. Alright. Now the last part, I'm going to have you guys do on your own, see if you can figure it out. Find out how long it would take to fill the cylindrical tank with water. Using this pipe of diameter 2.5 and a water flow rate which is constant, so not changing ever, and it's 30.562 meters cubed an hour. So the water is flowing at this rate. The diameter is this. And how long would it take to fill a cylindrical tank? And I don't mind if you give me it in hours or you give me it in seconds. Most people gave me the answer in hours, I think. And it's the same cylindrical tank as we described up here. So it's this cylindrical tank with that volume you just found.
So it would just be 2.5 divided by 30.
Let's see if we can figure it out. Okay. I'm going to figure it out real quick, and then I'll come around and check your answers. We'll say whoever figures it out first, we'll get prizes too, right? I got some prizes. I got to turn that off so I can figure it out. Now remember, don't overthink it. I think a lot of people overthink it.
Height's 12 again.
Yeah, so the height and radius will be from the same cylindrical tank that we used above. Alright. So your answer, well, I won't tell you your answer, but I'll come around and check your Alright. Actually, this thing died, but I think it was still recording over here, which is cool. And I'll push this.
It's the same time, right?
Hmm?
Same time.